All right, welcome to chemical reactions. This is just kind of an introduction. So first of all, what is a chemical reaction? Chemical reactions are when two or more substances interact in order to produce things that are different. In your chemical reaction, we start off with original bonds and they are broken. And to break your bond, you need to take in energy, absorbed. The way I think about this is you've got your security blanket. You've got your favorite toy if you're a kid. And all of a sudden, somebody wants to come and take that favorite toy or security blanket away from you. You're not going to offer that up easily. You're going to have to put in a fight. You're going to have to take in energy. So that is kind of what's happening. Your substances are stable. To break that original bond, you would have to disrupt the stability, which it's not going to do without taking in some energy. After that happens, your atoms are rearranged in some different way, and then we have new bonds formed. And when those new bonds are formed, energy is released. It's like you get your favorite toy is coming back. So you're stable again, you're happy, energy is given off. It's like the sigh of relief. That's the way I think of it. Because this is a little bit different than you would normally think. And that's when you see a chemical change occur. And we've talked about chemical changes before. Those are things like precipitates. Those are things like temperature changes, either energy given off, exothermic, or energy absorbed, endothermic, all that kind of stuff. So in a chemical reaction, we have what we call the reactants. The reactants are whatever on the left of the reaction arrow. These are the beginning substances. These are the things that undergo the change, chemical change. After the reaction, we have what we call the products, things that are produced. To the right of the arrow, these are the ending substances. And then, of course, we need our reaction arrow, which is in the middle. The reaction arrow is what shows the change. If you were ever to see it written out in words, you would see synonyms like yields, combines to form, decomposes, changes into, blah, blah, blah. What you would not see is equal. These are not equations. Every once in a while, you'll see these called chemical equations, and that's a misnomer because they are not equal. After the change, we form something completely different. So it's a chemical change, chemical reactions. So you do not say equal, do not say equation. So here we have an example. We have two reactants. We have potassium iodide and lead 2 nitrate. And then something happens. We have a change, and then we have two new products formed. We have potassium nitrate and lead 2 iodide. Notice we don't have something random like tungsten in there. That couldn't happen because that would defy the law of conservation of mass and energy and matter. And you cannot create a brand new element from that. All we have are the building blocks in the reactants. So here it is. We might have done this on a micro scale. This is a macro scale or larger scale. Look at all of that yellow substance being produced. So you've got two clear colorless liquids coming together, and then a yellow precipitate is being formed, which is actually the lead 2 iodide. So a solid being formed out of two clear colorless liquids is a brand new product. It's a totally new substance. So chemical change has occurred. Now, you might be looking at this chemical reaction and noticing something. You might be noticing that on the reactant side, we have two groups of nitrate. So we have 2 nitrogens and 6 oxygens. But on the right side, the product side, you notice that we only have one group of nitrate, 1 nitrogen, 3 oxygens. And that would show a loss of mass, a loss of atoms. It actually didn't lose anything, but this is what we call an unbalanced chemical reaction. And so because of that, we're going to need to figure out how to balance chemical reactions to maintain the law of conservation. And that's where we'll go next. Thank you.